I think I expect everyone to have joined before 7, so people are still joining. So that's why we send the link 30 minutes to the class. So let's start. So good evening, Ma. Good evening once again. So tonight, we're going to be checking the basic statistical method in Nexin. So the class rep sent me the slide that the lecturer is using to take this course. So I've gone through the whole slide. So I've tried to make it simpler so that we can understand. So aside from this class, after this class, you'll be able to undo any question that pertains to that related to statistics, and then that relating to the apply of statistics in medicine, whether you are in clinical sciences or you are in nursing or you are in public health. So you'll be able to understand it and solve the real life situation. So for the course, you are going to pass the course very well, very, very well. But beyond the course, this course is going to cover you beyond the course that you are studying. So let's move. Now, the first thing that we have to understand is that statistics is divided into two. Statistics is divided into two. That's the first thing that we will have to understand. So statistics is divided into two. We have descriptive statistics, and then we have inferential statistics. We have descriptive statistics, and then we have the inferential statistics. So there is another aspect of statistics called probability. Probability type is not categorized under the division of statistics, but we normally use it to form a model. There are a lot of models that we normally formulate in statistics. So we normally use probability to do that. So, but majorly, statistics is classified or divided into two. We have descriptive statistics, and then we have inferential statistics. So we're going to be starting with the descriptive statistics tonight. So subsequently, we are going to talk about the inferential statistics and also talk about the probability. So under the descriptive statistics is also divided into two. Descriptive statistics is also divided into two. We have the graphical method, and then we have the calculating part of descriptive statistics. You have to get that one right, that anytime you are picking descriptive statistics, ask yourself, did I want to perform the graphical method, or I want to perform a calculation method in descriptive statistics? So under the graphical method, we have the bar chart, we have the pie chart, we have the histogram, we have the box plots, so many things that we have under the graphical part of descriptive statistics. But the beauty of descriptive statistics is that immediately you understand the concept of the the concept of graph, you'll be able to represent your data graphically, whether through bar chart or through histogram or through pie chart or through box plots. So that is the part of the graphical part in descriptive statistics. So the other part of descriptive statistics is also divided into two. The calculating part of descriptive statistics is also divided into two. Sorry, I'm trying to admit people as they are coming in. Into two. The first one is what we call the measure of location. Another name is called measure of central tendency. Anytime you are hearing a measure of location or measure of central tendency, they are referring to what's called the mean, median, and mode. Please note that the mean, the median, and the mode, three of them are called the measure of location. We normally use it to check the average number of data that we have. Let me admit these people. So we normally use that to find and describe the data that we have. Okay, in the set of we have like 10, let's say for instance now we have 46 people in this class. Okay, we want to check the average age of the 46 people that we have in this class. So that means that if everybody submits their age, so we're going to do what? We're going to find the mean. The mean is also called the what? Is one of the central tendency or measure of location. So we have three under that, which is the mean, the median, and then the mode. Is very, very important. So as we are going on tonight, we're going to be checking that. Another one that we have is what we call the measure of dispersion. Remember that under the calculating part of descriptive statistics, we have two. We have the measure of location or measure of central tendency, is still the same thing, and measure of dispersion. measure of dispersion. So under the measure of dispersion, we have the range, then we have the what's it called? We have the variance, we have the standard deviation, we have the skewness, we have the kurtosis, and then we have what we call the coefficient of variation. Under the measure of dispersion, we have the range, we have the variance, we have the standard deviation, we have the skewness, we have the kurtosis, and then we have what we call measure of dispersion, or what we call the coefficient of variation. So coefficient of variation is also part of measure of dispersion. So we are going to be checking that in this class. So in statistics generally, whether about statistics or economic statistics or any form of statistics, it's either we have group data or ungrouped data. It's either we have group data or ungrouped data. What did I mean by group data? What did I mean by ungrouped data? So let's start with ungrouped data. Like I said the other time, let's say for instance now, I want to find I have the data of the age of total students that I'm having in this class. So those data are not arranged. Let's say for instance now, as you are entering this class, I'm taking note of your age. I'm taking note of your age. I'm taking note of your age. At the end of this class, let's say I have 40 students that attended this class. So if I'm adding your age one by one together, the age of the first person that entered the class, plus the age of the second person that entered the class, plus the age of the third person that entered the class, up to the age of the last person that entered the class. So if I divide it by the number of observations, so that means that I have the mean for ungrouped data. So that means that your data as you are entering is not grouped. I did not group that data, so I just have it raw. So what did I mean by the group data now? Let us now say, for instance, now I want to put those people that are in between the age of, let's say, 20 to 40 together. So that means that anybody in this class that is between the age of 40 to 20 to 40, I'm going to group them in one side. Anybody that is within the age of 41 to, let's say, 60, I'm going to group them into another one. Anyone with the age of 61 to, let's say, 80, I'm going to group them to another one. So in that case, we have what we call a group data. In that case, we have what we call a group data. But if we did not group it, we call it ungrouped data. So we have different formula for calculating that. So we're going to start with the mean of ungrouped data. The mean simply means that add everybody that is in that class together divided by the number of people that is in that class. What did I mean by that? If you look at this, my slide, I'm having the mean is equals to this symbol that you are seeing here is what we call the summation, but you can call it addition. The symbol simply means that everybody in this class add them together. That is the meaning of this symbol. We call it summation. So that's why we normally call this summation x. So summation x over n. N here means the number of people that is in this class. We normally call it the number of observation or the number of data that we have. But the summation means that add every single data that you have in this class together. By the time you divided it by the number of observation that we have, you are going to get what we call the mean. But in that case, the mean that you have in that case is what we call the mean for ungrouped data. It is called the mean of what? Ungrouped data. So where these x are what? Are data sets given from the question. Let's say you are given a question to solve. Okay, you are given the let's say for instance now we have the sample of the blood pressure of 10 students. So each one are the x's. The student 1, the student 2, the student 3, the student 4. They are the x's. That they are the data that we have for their blood pressure. So by the time you add them together, the 10 blood pressure that you have, by the time you add them together, you have this numerator, which is what? Which is summation x. So now divided by how many blood pressure did you add together? It's just 10 divided by 10. The 10 there is this n. So by the time you do that, you have performed what we call the mean for ungrouped data. We have performed what we call what? The mean for ungrouped data. So that is number one. Then number two is what we call the mode. How do we get the mode for ungrouped data? Remember that from our secondary school, we believe that the one that appears most is the mode. Yes, it's still valid till the higher institution. If you are having ungrouped data, the one that appears most is the mode. Let's say, for instance, like I said the other time, for the student blood pressure, 10 student blood pressure. Let's say, for instance, now among that, we now have those that are, let's say, three of them, they measure 120. It's just an hypothetical data. They measure 120, and others we have 80, we have 90, we have 100. At the end of the day, we have those people that measure like 120 to be more from that what from that 10. So that means that the mode of that data set of that student blood pressure is 120. So it's the one that appear most. The one that appear most in ungrouped data, it is called the mode. That is for that. Now, the last one under the measure of location is what we call the median. The median. The median simply means that the one at the middle. But there are conditions for selecting median. Please and please, I want us to listen to this. There are conditions for selecting median. Anytime you are having ungrouped data, we've explained ungrouped data. Anytime you are having ungrouped data and you want to find the median, the first thing is that you have to arrange them. You have to arrange down your data. It's either you follow ascending order. What did I mean by ascending order? It means that you are going to start from the smallest to the highest. That is what they mean by the ascending order. It's like you are climbing step. One step, second step, third step, fourth step. So that is what we call the ascending order. So you are going to arrange your data like that. So by the time you arrange your data like that, then you will now divide that data into two parts. Let's say, for instance, now I have 7 data points. Okay, after I've arranged them in ascending order, so at the time I'm going to divide them into two. To my right hand side, I'm going to count 3 because I'm having 7. I'm going to count 3 towards my right hand side. Then I'm going to count 3 towards my left hand side. So the one at the middle is what we call the median. The one at the middle is what we call the median. You may ask me this question: what if it is not 7? What is an even number? The even number simply means that, oh, if you divide it into 2, you don't have anything that is remaining. Let's say, for instance, I will now have 8 observations instead of 7. Now, by the time you count the 4 towards your right hand side, you count 4 towards your left hand side, you won't see anyone at the middle again. But after you've counted that 4, instead of now counting 4, you count 3. By the time you count 3 to your right hand side, you will count 3 towards your left hand side. You are going to have 2 that is remaining at the middle. So that 2 that is remaining at the middle, you are going to add them together, divided by 2. That one that is remaining at the middle, you are going to add them together, divided by 2. Then you will have what we call the median. So you can now say, oh, the median of systolic blood pressure of these 10 students is this. So this is how we normally find the measure of location for group data. So let's continue. By the time I spend 1 hour, an hour, I'm going to give room for questions, so that I'm going to give like 10 minutes so that we can ask questions, then we move on again. Thank you. So let's continue, please. So now I have this example here so that it will not look like abstract. It will not look like as if we are talking in logic form. So this is the real life situation. These are the status of the smoker liver. This one was extracted from the smoker group. So they measure the amount of the damages that the smoking has caused to their liver. So they recorded this number. If you look at this number, this particular data that you are seeing here, they are ungrouped data. They are on what? They are ungrouped data. So now this one is for non-smoker. Those people that they don't smoke, we have their what? We have their number here. So the first thing is they want to calculate the mean of the smoker and then the mean of the non-smoker. We want to get the mean of the smoker and then the mean of the non-smoker. If you look at the mean, look at this now. Since this is on group data and I want to get the mean, remember I told us that we are going to add all these observations together. We are going to add all these observations together. So look at this now. For the first one, the summation means that addition. This summation means addition. So the reason why I'm putting X1 here is that I'm considering this smoker first. That is why I'm putting it there. So it's going to be, look at this first one, it's supposed to be 0.03, then plus 0.01, then plus 0.01, plus dot, dot, dot. In mathematics, please listen to this. This is very, very important. Instead of you writing the whole 12 that we have here, because of your time, it is acceptable in mathematics when you write the first one, the second one, and then the third one. You can put 3 dots. The 3 dots simply means that you are continuing. Then you will supply the last one. If you look at this last one here, is 3.80, which is this. Remember that the first one is 0.0, it's supposed to be 0.03 when I was stamping it. So I will put 0.030 here before I send you this slide. So I'm going to make amendment of that. So this is 0.03 plus the next one, 0.01, plus the next one, 0.01, then plus 3 dots means it continues. Then you will supply to what? You will supply the last one. So by the time you do the addition of these together, we're going to have what we call 11.21 divided by 12. We're going to have 0.9342. So by the time you approximate this to the 1 decimal place, what did I mean by 1 decimal place? It means that after this point, you need just one number. That is what they mean by 1 decimal place. In your exam, the instructor can give you, or the examiner can tell you that leave your answer in 2 decimal. If it is 2 decimal, after the point, count to 1, 2. But before you remove all this one, check whether this one is greater than 5, is up to 5. Well, if this 4 is up to 5, you are going to approximate it to be 1, then you add it to 3. So it's going to be 4, assuming this 4 is 5. So if your examiner asks you to leave this one in 2 decimal place, it's going to be the first one, dots, then you are going to count 2 after the dot. If the examiner asks you that, oh, leave this thing in 3 decimal, so that means that after the point, you are going to count 3, which is 1, 2, and 3. So that is for that. Now, let us check the one for non-smoker. For the non-smoker, you are going to apply the same thing, 0.45 plus 0.75 plus 1.40, then plus dots, 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 then you put the last value here. And then the last value here is 3.55. By the time you add them together, which is the same thing as summation, we are going to arrive at 28.63, then divided by 14. By the time you make this division by 14, you are going to have 2.045. We can then approximately to 1 decimal place, which is equals to 2.0. Why? Because if you look at the number that follow after this decimal, is just 0. But before you leave it at 0, check the next number. The next number here is 4, and then this one is not up to 5, so you cannot round it up to be 1 that you are going to add to this. So we are going to round it down. So we have our answer to be 2.0, which is for the mean of these 2 ungrouped data sets. Now, let's say we want to find the median. Remember that I said something the other time that it's either you arrange your data set in ascending order, that means that you are starting from the lowest to the highest, or you arrange it in descending order, that means that you are starting from the highest to the lowest. Anyone is okay, and then it's mathematically correct or statistically correct. So if you look at the data of this smoker that we have, if you look at it from here, let me go back a bit so that I can show you the data. The first one here is 0.03, but if I want to arrange it now, the first one will come first. The first one is going to be what? 0.01, followed by 0.01 again, followed by 0.01, followed by 0.02, up to the last one, which is 3.80. So that means that I have rearranged this in ascending order. So for the median, we need to first rearrange in what? In ascending order or descending order. So after that, now if you look at this value that I have here, if you count it, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is an even number, not odd number. So now I have 12 here. So that means that instead of counting 6, 6, I'm going to count 5 towards my right hand side. I'm going to count 5 towards my left hand side. If I count 5 towards my right hand side, I'm going to have 3.80, 2.55, 1.52, followed by what? Followed by 1.12. That is number 4. Then number 5 is going to be 1.01. So that is 5 towards my right hand side. Now, towards my left hand side, you are going to count the same 5. 1, 2, 3, 4, 5. So after that, we are left with 0.52 and then 0.61. So we are left without 2. Let me move to this person. So we are left with what? 0.52 and 0.6. So by the time you add them together, divided by 2, you are going to have the median. So approximate this to 1 decimal. This is what I'm now saying the other time. If you look at this, the first number that follow this decimal is 5. But before you leave it like that, check the next number. The next number here is 6. By the time you do the approximation, this one will become 1. Then you will add that 1 to this. By the time you add that 1 to this one become 0.6. So now to 1 decimal now, the answer here is 0.6. Okay, someone is raising up hand. Oluwatosin, do you have any question with that? Please. Please, can we continue?
Please, sir, can
you hear
we
me,
go
please?
over the median again? I don't understand. Please, can we go over it again, the median?
Oh, okay. Okay, we are going to do that. Please, any other question again? Can you hear me, please?
Yes.
Yes,
We can hear you.
Yes, we can hear you, sir.
Okay.
Yes, we can hear you, sir.
Okay, so let me go over the media again. Let me go over the media again. Now, for the ungrouped data, immediately you are given a data that is not grouped, and they ask you to find the median. The first thing that you are going to do is you are going to rearrange your data sets. It's either you use ascending order or you use descending order. What did I mean by the ascending order? It means that you are starting from the lowest to the highest. It's like a staircase that we climb. So you are going to take the first one, you move to the second one, you move to the third one, you move to the fourth one. So that means that you are moving from the lowest to the highest. That is what they mean by the ascending order. But if you are the type that you love descending order, no problem. So that means that you are starting from the highest to the lowest. So that means that that top of your staircase, you are climbing it down. So that means that you are starting from the highest, moving down to the lowest. So that is the part of rearrangement for the median. Now, after you've rearranged your median, then you are going to check that number. The number that I want to work with, is it odd number or even number? Now, what did I mean by odd number? By the time you can't, let me use a layman language that you can understand. I don't want to use a statistical word so that we can understand. That means that by the time you divide it by 2, you are going to have remainder. So any number that you divide by 2 and you have remainder, so that means that it is not an even number. So any number that you divided by 2 and you don't have anything left, that you have a whole number, you don't have dot something. So that is what we call the even number. I've admitted everybody. I'm saying let people enter. I've admitted everybody. We are 62 in number now. So that is what they call the even number. So let's say, for instance, now you now have odd number. You have odd number now. So that means that, let's say we have 7. After you've rearranged, we have 7. So that means that you cannot divide it equally. So that means that we are going to count 3 towards your right hand side. You will count number 3. So starting from the highest number, you will count 3 towards your right hand side, and then also you will count 3 from your left hand side. So at the end of the day, you have a number at the middle. The number that you have at the middle is what we call the median. So that one is for the what? For the odd number. When you have odd number. Now, if you have even number, that means that if you divide it by 2, you are going to have exactly that number. You are not going to have any remainder. So that is what they mean by the even number. Let's say, for instance, now 2 is an even number, 4 is an even number, 6 is an even number, 8 is an even number, 10 is an even number, 12 is an even number. Let's say, for instance, now we now have a data set of 10, which is even number, and you want to find the median. The first thing that you are going to do is record that you are going to rearrange whether ascending order or descending order. Now, after you've rearranged that, so that means that, oh, now that I'm having the even number, that is 10. So if I count 5 towards my right-hand side and I count 5 towards my left-hand side, I will not have anyone at the middle again. So does that now mean that there's no median? No. So in that scenario, instead of counting 5, 5, you are going to count 4, 4. So that means that if you are starting from your right-hand side, you are going to start counting the 4 from your right-hand side. You count the 4. At the end of the day, you have one left at the middle. By the time you start from your left-hand side also, by the time you count that 4, you will still have another one left at the middle. So at the end of the day, you are going to have 2 data sets left at the middle. So that 2 data sets, you are going to add them together. You are going to add them together, then divided by 2. Add them together, divided by 2. So by the time you divide it by 2, the answer that you have at the end of that your division is what we call the median. The answer that you have at the end of that division is what we call the median. Am I clear, please, about the median?
Yes, sir. Yes, sir. Very much.
Yes,
Hello, sir. This one that you did is 0.52 and 0.61. I am just using 0.52 and 0.6. How about the one in front of 6?
That's a very good question. Is 0.61. So add 0. Can you confirm this for me? 0.52 plus 0.61 divided by 2. So that means that you are really following us. You can use your calculator to confirm that. What do we have?
So 1, 2, 3, 4, 5, 6.
We have 0.565.
0.565.
I have 0.565, which is the same thing as my answer. So please, it is 0.61. It is 0.61. Thank you for that observation. So that means that you are really following the class. Okay. Someone is putting up hand again. So can we move on, please? I'm going to take further questions later so that we can cover what we have for this class. Okay, Mureni Keji, you are raising up your hand. Do you have a question or? Okay, let's move on. So if we do the same thing for the second one, then we're going to have our median. Please let's move our mic.
Hello, can you hear me, sir?
Yes, I can hear you.
Yes,
I'm trying to mute this person. I can hear you, ma. Please go ahead. You have a question?
Hello, sir.
I can hear you, please.
My question, okay, sir, thank you. My question is, can't we approximate from the last figure? Like we have
I can't hear anything again, no.
Please, ma, maybe we should let him finish before we ask questions.
Okay.
Please let him finish before we ask questions. We are just wasting our time.
Okay. Can you hear me now? So let me quickly react to questions so that we can move on. What I mean is that if you look at the one that we have here, if the question asks you that leave your answer in 2 decimal, so that means that you are going to count the first 2 number after point 1, 2. Then before you now round down the last number or you discard the remaining number, you are going to check whether the number is up to 5 or less than 5. If it is up to 5, so that means that you are going to approximate it to be 1 and add it to the what? To the next one, which is going to be what? 0.57. But if the question asks you that you should leave your answer in 1 decimal, so that means that we are going to have it as what? As 0.6 that we have. Is that clear, please?
Yes, please.
Sir.
Okay.
Yes, sir.
Okay, so let's move on.
Yes, sir. Thank you, sir.
Okay. Now, they can ask you this. This is one of the questions that we have for our student, the past student that wrote this particular exam of yours. It's also about statistics. Please, let's mute our mic, please. Okay, so now is the mean is an accurate indicator of this and this. Now, let me quickly state this. The reason why I'm bringing this thing is that please give me a minute. Let me mute everybody, please.
But do some.
Please, can we all mute our mic, please? Okay. So, there is the good part of we calculating mean and median is this. Olubukola Omotola, please can you mute your mic, please? Okay. So, the beauty part of we calculating the mean and the median is this. Please note this. This is very, very important. Anytime you calculate your mean and you calculate your median, and both of them are the same. Anytime you calculate your mean and you calculate your median, and both of them are the same, that means that that data that you use in getting those mean and median, they are normally distributed. That means that that data is normal. Another name for normal distribution is what we call that data is symmetric. So anytime you are calculating your mean and you are calculating your median, and they ask you, is that data symmetric or is that data normal? This is the thing that you are going to check. You are going to check the value of your mean and then the value of your median. So immediately the value of mean is equals to the value of median. So that means that you are that data is normally distributed. Please note that it's very, very important. But if that your mean is not equals to the median, so that data is not normally distributed. So that means that it is not symmetric. So we call it asymmetric. Let me take it again. By the time you calculate your mean and median, and your mean is equals to the median, that means that that data is normally distributed. But if your mean is not equals to the median, that means that that data is not normally distributed. So that is what they are asking them to do here. So now, if you look at the first one that we calculated, the mean is 0.9. It is not equals to the median, which is 0.6. So that means that it is asymmetric. That means that it is not normally distributed. Now, anytime, please note this also, anytime your mean is greater than your median, anytime your mean is greater than your median, we normally call it right skewed or positive skewed. Now, how do we know whether your data is positive skewed? Let me start from the skewness. How do you know that whether your data is skewed? Just check for this. When your mean is not equal to the median, your data is skewed. Please note that. Once you check your mean value and your mean value is not equal to your median value, that means that your data is skewed. Now you've established the fact that your data is skewed. Now, what type of skewness? Is it right skewed or left skewed? Is it positive skewed or negative skewed? So right skewed is the same thing as positive skewed. Left skewed is the same thing as negative skewed. Now, how do we know whether it is right skewed? Immediately your median, immediately your mean is greater than your median. That means that it is positive skewed or right skewed. Now, immediately your mean is less than your median. That means that it is negatively skewed or left skewed. Note that it is very, very important. But if you check for the non-smoker, if you notice the mean that we got for non-smoker, it is 2. And then the one that we got for the median 2, it's also 2. So that means that the data of non-smoker is normally distributed or it is symmetric. Please note that it is very, very important. So if you have any question, be jotting it down. Be jotting it down. So I'm going to take the question together because of our time. Now, that is all for the group data. Remember that when we started, for those people that joined late, remember that when we started, we talked about that the statistics is divided into 2. We have the descriptive statistics and inferential statistics. And then the descriptive statistics is also divided into 2. We have the graphical part and then we have the calculating part. So under the graphical part, we have the bar chart, we have the pie chart, we have the histogram, we have the box plot, then we can have stem and leaves and some other graph like that. Then under the calculating part of descriptive statistics, we have the what's it called, measure of location or measure of central tendency. It's still the same name. One person is bearing 2 names, measure of location or measure of central tendency. And then the second one that we have under the calculating part of descriptive statistics is what we call the measure of dispersion. So under the measure of location that we started with, we have the mean, we have the median, and then we have the mode. Under the measure of location, we have the mean, we have the median, and then we have the mode. But under the measure of dispersion, we have what we call the range. We have what we call the variance. We have what we call the standard deviation. We have what we call the kurtosis. We have what we call the skewness. And then the last one, we have what we call the coefficient of variation. Coefficient of variation. So we started with measure of location, which is mean, median, and mode. Then we now migrated towards data can be grouped or ungrouped data. So your data can be grouped or your data can be ungrouped data. Now we started with ungrouped data. That is when we have we use the mean to calculate the ungrouped data that we have, and then we also find the median, that the one at the middle is the median, and then the one that appears most is the mode. So now after that, we want to check whether the mean that we've calculated, whether the data that we calculated mean from is normal distributed, whether that data is normal or it is not normal. How do you check whether data is normal or it is not normal? By the time you see that your mean is equals to your your median, that means that data is normal. But if your mean is not equals to that your median, that means that your data is not normal. You have to establish that. Immediately you establish that your data is not normal. Good. Okay. Is it positively skewed or negatively skewed? If it is positively skewed, it means that your mean is greater than your median if it is positively skewed. But if it is negatively skewed, that means that your mean is less than the median. So let's move on, please. So now we move to the grouped data. We move to what? Grouped data. Now that we now have grouped data, how do we calculate the mean for grouped data? The formula to calculate the mean for the group data is what we call, remember that I told us that this particular symbol, it is called summation. That means that it is called, you add them together. Add them together. So now remember that from the ungrouped data, we only have X, summation X. Now for the group data, we are going to introduce F. This F is called the frequency. The F that you're having here is called the frequency. What did I mean by that? Let's say, for instance, now, the age of total, I'm taking the age of total students in this class. Okay, I have from age 20 to age 60. Let's say, for instance. Now, I want to group them. Oh, from age 30 to age 30. How many people fall within that range? So the number of people within the range of age 20 to age 30 is what we call the frequency for that age. Now, let's say I still move further from age 31 to age 40. The number of people that fall within the age 31 to 40 is the second frequency for that age group. Now, let us now move further that we have from 41 to 50. Everyone that fall within the age of 41 to 50 is what we call the frequency. That is what they mean by the frequency. So by the time we multiply the frequency by the x that you are seeing here is not all those data. Remember from our ungrouped data, I told us that each x are the data. But in the case of group data, it's not like that. I'm going to show you how you can get your x for grouped data. So now the same thing divided by the f is the total observation that you have. Summation f now is now the total observation that you have divided by this. You are going to get the mean for ungrouped data. I'm going to show us with examples so that we can understand these statistical jargons. So now the mode formula to calculate the mode is we have the L plus we call this one D1, but in mathematics we call it change in one. But if you write it as D1 or change in one, they will mark it for you, divided by change in one plus change in two. Then this one means multiply by C. Multiply by C. This is the formula for calculating group data for mode. The group, once you have a group data and they ask you to calculate mode, you don't use the one that appear most, like the ungrouped data. You are going to use this formula. How we can use this formula, we are going to see it in this lecture. So now if you look at it, the LEM means lower class boundary of the modern class. That means that you first of all get the modern class. I'm going to show us with that. By the time we do the example, we are going to understand better. Now D1 means that is the difference between the frequency of the modern class and frequency before the modern class. That means that once you locate your modern class, a modern class will have frequency. Please note this. Modern class is the one with the highest frequency. Note that in your notes. Modern class is the one with the highest frequency. So if you have the highest frequency, to now get the D1, it means that the difference means that the minus. So that means that the frequency of the modern class minus the frequency before you get to modern class. I'm going to show us in our calculation. Now the D2 means that the frequency of the modern class minus the frequency that follows the modern class. After the modern class, the frequency that follow it, you subtract it from the modern class. That is how we get our D2. Now we have the class width. The class width is what is the range that we have. Let's say for instance now from age 21 to age 30. How many number can we get? Let's say for instance now 21, 22, 23. By the time you count it up to 30, the number that you can have within that range is what we call the C. I'm going to show you how you can quickly get it from your data by the time we get to the example. Now the same thing go for the median. The reason why I'm showing us all these formulas first before I show you the example is that because by the time I'm showing you the example, I'm going to be showing you how you can extract all these parameters that you are seeing, all this N, all this L, all this FM, and some other things that you've seen so far. I'm going to be showing you how you can bring it out from your data, because you'll be given data, and if you are given data, they will expect you to calculate all these things. So how you can get it without stress, you are going to see it in this lecture. Now the same thing go with this. We have the lower class boundary of the median class. I'm going to show you how you can get your median class. The N is the total observation. Then if you see this one, that is why I have to put it like this, so that I'm going to be saying it one after the other. If you check textbook, they will not simplify it like this. But I know my students, I know the people I'm dealing with, that I have to bring it down to the level that they can understand. So that's why I simplify it like this. I'm going to tell you the meaning of this. This one simply means frequency. This F that you are seeing here is frequency. Now forget about this capital F that you are seeing here. All this one that you are seeing is the source script. That means that it is under this F. It is not the same thing as FC. So this one is simply means that cumulative frequency before the median class. That is why I put it like this. Cumulative. C here means cumulative. F here means frequency. B here means before. M here means median. Then C here means class. But you can't see this in your textbook. But for you to understand it better, that is why I put it like this. So that means that this one that you are seeing here means cumulative frequency before the median class. Cumulative frequency before the median class. So let's move on. I'm going to give room for question. So before we get to the calculation, I'm going to give room for the question. So let's move on, please. So now the FM means the frequency of the median class. The frequency of the median class. That is what we call the FM. And then C is the class width for this median. Okay, so before I move to this calculation, let me welcome two questions. That is how I'm going to know whether this teaching is effective or not. So please, two questions, please.
Well done,
Hello,
sir.
sir.
Thank you for the presentation, for the teaching. How do we calculate the mode for ungrouped data?
Okay.
The mode.
The one that appear most.
Okay.
The mode is the one that appear most.
For the ungrouped.
Yes, that is for ungrouped data.
All right.
Yes,
Thank you.
the one that appear most.
All right.
Okay. One question more.
Hello, sir. Since you started the group data, the slide was not showing.
Are you not seeing my slide, please?
It just appeared now. It was not showing
It's
since
your
you started.
network.
Maybe it's on your side.
Please check your network. Please check your network. So that hello, I'm going to.
Okay.
That is why if I'm taking online class, I always give room for. I always record my class so that I can share you because of this network issue, so that you can go over it again and again. So this lecture that we're taking tonight is going to be ready latest by, let's say, 3 a.m.
You want to appear most.
So they are going to send me this. So I'm going to share you the link. So any other question before we move on? Okay.
The slide is not showing, sir. Mine is not showing.
It's showing. It's your network. It's showing.
But he just addressed that is on your phone.
It's showing.
Please check your network. It's showing. Check your network.
Check your
Check
screen.
your network. On your screen.
Okay, let's move on, please. Now, if you look at this, please, let's mute our mic. Let's mute our mic. If you look at this now, we have what we call the class interval. We have what we call the class interval. What did they mean by class interval? It's just the range. Like I mentioned the other time, let's say I have the age now. Oh, let's say I have the age now. Okay, from 60 to 69, they are in this group. So the frequency I'm talking about the other time is that when I count people from this group, from age 60 to 69, they are just 3. So that means that from this age group, we have just 3% in this age group. That's what I mean by that frequency the other time. Now, if you are moving now from 70 to 79, that means that in this age group, we have what? How many people within this age group is just 7. Then if we move to the next one, we have from 80 to 89. How many people do we have there? We have just 9. Then if you move now from 90 to 99, how many people do we have there? We have just 12. Like that, up to the last one. That is what I mean. That's how we get our what? Our frequency. So if you are given on group data, you can group it. So you can group it, and therefore uniformity, so that you can have equal answer. They will give you the class interval that they want you to use. They will give you what the class interval that they want you to follow. So don't be scared about the class interval they are going to give you. So one thing that you just need to notice is that once you are given the class interval, you will go into that your own group data and look for those numbers that are within the range of this. Once you count it, you put it there under the frequency. So that is it. Then the same thing go for this, the same thing go for that. That is number one. This is very, very important. Now, if you look at this, the third column here, it is called cumulative frequency. From the word cumulative, that means that add them together. Cumulative. So that means that we are summing them iteratively. I don't want to use mathematical words so that you can understand. It means that we are going to be adding them together step by step, step by step, step by step, step by step. What did I mean by that? If you look at the under our third column here, that I wrote cum dot frequency, it just simply means cumulative frequency. How do we get cumulative frequency? Cumulative frequency simply means that the first frequency that you have here is 3. Take it to there. Now, the next one here is going to be 3 plus 7, which is the second frequency here, is going to be 10. That's how we have this 10 here. The next one, 19, that you are seeing here is going to be 10 plus 9. We have 19. The next one that you are seeing is going to be 19 plus 12. We have 31. The next one that you are going to see is going to be 31 plus 9. We have 40. The next one that you are going to see is going to be 40 plus 7. We have 47. Then the next one that you are going to see is going to be 47 plus 3, which is 50. Now, please note this. Immediately, the last value that you have here must equal to the total frequency. If you look at it, they are 50-50. If what you have here is not equal to the total frequency, that means that you are wrong. It is very, very important. The last value that you have here must equal to the total number of frequency that we have here. That is what we call the cumulative frequency. Please note that it is very, very important. Now, how do we get our X? Remember that from our ungrouped data, I told us that those values that you are given are your X's. But immediately we arrive at the group data, how do we get our X's? This is how we get our X. Now, our X is what we call the middle value. The middle value. What did they mean by the middle value? Now, come back to your class interval. The first class interval that I'm having here is 60 and 69. Add them together. 60 plus 69 divided by 2 will give you the middle value, which is 6.4. That is the X for the first one. The next one is 70 plus 79 divided by 2. We are going to have 74.5. The next one is 80 plus 89 divided by 2. We are going to have 84.5. The next one is 90 plus 99 divided by 2. We are going to have 94.5. Now, let me now tell you this. As a smart student in the exam, once you find your class width, let me tell you how you get your class width. Please note this. I'm still coming back to this. How do you get your class width, which is our C? The class width simply means that the highest value that you have in this range, you know, this is 60 to 69. The highest value that you have here is 69 minus 60. 69 minus 60 is going to give you 9. Add 1 to it. That is 10. So the class width is 10. If you look at this guy too, 70 to 79, 79 minus 70 is going to give you 9. Add 1 to it is going to give you 10, like that. But if you are the type that you don't really understand this concept in the exam, or you can just count your finger starting from 60. We are going to have 60, 61, 62, 63, 64, 65, 66, 67, 68. By the time you get to 69, you discover that it is 10. If you count it, you discover that it is 10. But if you are the one that you are a sharp guy, or you are a sharp madam, so you can quickly do what? 69 minus 60 is going to give you 9. Add 1 to it, you are going to have your 10. So that is what we call the class width. The class width, which is our C that we are seeing in those formula, the class width. Now, let us now come back to the middle class, the middle value. So by the time you get the first one, once you know your class width to be 10, add 10 to the first one, you are going to get the second one. It's going to be 74.5. Add 10 to 74.5, you are going to get the next one, which is 84.5. Add 10 to the 84.5, you are going to get the next one, which is 94.5. Add 10 to 95.5, you are going to get the next one, which is 104.5. Add 10 to 10.5, we are going to get the next one, which is 114.5. Add 10 to it, we are going to get 124.5. Instead of you typing your calculator, 70 plus 79 divided by 2, 80 plus 89 divided by 2, 90 plus 99 divided by 2, you can quickly get your middle value like that. So record that. Remember that in our own group, group data, our mean is summation fx over summation f. Remember, let me quickly go back there so that you can see. Remember, this is our formula for group mean, for the group data, summation fx over summation f. So let's go back to our table. Now, the next thing that you have to find out is the summation fx. Which is this guy. How do we get it? It simply means that the f that you are having here multiplied by the x that you are having here. So that means that 3 multiplied by 64.5 is going to give you 193.5. You move to the next one. 7 multiplied by 74.5, you are going to have this value. The next one is 9 multiplied by 84.5, you are going to have this value. The next one is 12 multiplied by 94.5, you are going to have this value. The next one is 9 multiplied by 9 multiplied by what? 104.5, you are going to get this value. The next one is 7 multiplied by 114.5, you are going to get this value up to the last one. So by the time you do that, you've calculated your what? Fx. Fx. Remember that the formula for finding the mean for the group data is summation Fx over summation F. So how do we get summation Fx? Summation means add them together. You've gotten your Fx, add all these Fx together. By the time you add them together, we are going to have 4,725. So that means that you've calculated the numerator for your mean for ungrouped data, which is summation Fx. So the summation Fx is this, which is 4,725. Now, the denominator, recall that the denominator is summation F. Summation F simply means that add all the frequency that you have together. By the time you add all this frequency that you are having here together, we are going to have 50. So now the denominator, which is summation F, is equals to 50. Now you can now find your what? Your mean. So how do we now find our mean? Quickly put it inside our what? Our formula. By the time you put it inside our formula, let us look at the next slide. By the time we do that, mean is summation Fx over summation F, which is the summation Fx that we've calculated is 4725 divided by 50. By the time you divide this by 50, our mean is going to be 94.5. Our mean is going to be 94.5. That is how you can get your mean for the what? For the group data set. That is how we get our mean for the group data set. So don't let me assume that everybody just understand what I said so far. So for the any question, let me welcome 2-3 questions, then we move on again. Bisola, you can ask your question.
Yes, sir. Well done, sir. Thank you very much for the lecture. Now, back to the class interval, sir. You know, you gave us a range between 60 to 69, 70 to 79, blah, 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 like that. What if the class interval, we are not giving a range? Probably we are giving a particular number, probably 60, 70, 80, 90, without range like that. How do we now get our FX? How do we get
That's a very good question.
yes.
The interval.
Yes,
That's a very good question. Yes, that's a very good question. There is one formula called the Stooges rule. There's what we call the Stooges rule. But when I was going through your slide, they didn't make use of Stooges rule. Stooges rule is the rule that we normally use to get our class interval. What is Stooges rule? The Stooges rule simply means that we are going to have what we call the range divided by k. Range divided by k. That is what we call the Stooges rule. Range divided by k. Remember, when by the time we get to measure of dispersion, range simply means that the highest number minus the lowest number. So if you are not given that the interval, that means that you first of all get your range by checking those values that you have. Which one is the highest number? Highest number, let's say for instance, now your highest number is 120 and your lowest number is, let's say for instance, is 50. By the time you do the subtraction, your range is going to be 70. That means that you've calculated your R. Now, what is your K? This is where you have to, this is now where you are going to calculate a bit. What is now your K? K is now equals to 1.33, then the log of n. K is now equals to what? 1.33, then the log of x. If I still remember the Stooges formula. So by the time you now, what is the log? What is the n? N is the total number of sample that you have. So the total number of sample that you have, you will take the log, then multiply by, I think, 1.3333. So that is, by the time you do that, you are going to have your K. So your range value divided by your K will give you the interval. So I'm not sure about that, how to get that K. That K, I'm not sure, maybe that formula is correct, but I know it is 1.33 log of n. So that is how you get it. But for the uniformity, they normally give range. But in case you are not given the interval range, that is how we normally get it. But when I checked your slide that was sent to me, what's it called? The range was given, so they didn't mention anything like stooges, So that is for that. So if I'm going to check my previous slide, so I'm going to write the what's it called, the formula to get your interval for you. Then I'm going to send it to class rep, so the class rep can send it to group. So that is for that. So that is how we normally get the range. But most questions, like for instance now, those in public health and the clinical sciences, they normally give them the range, the interval that they should work with, so that they can have the same answer. So anyone, let me welcome one more question before we move on. Any question again?
Thank you, sir. Yes, sir.
You're welcome.
Excuse me,
Well
sir.
done, sir.
Please go on.
Can you kindly repeat how to get the width?
How to get what, man?
That you started adding. How did you
How
get
to,
the 10?
how to get what, man?
Width.
The shortcut to calculating the class width.
Oh, good. Okay, the shortcut to calculate the class width is simply means
Loss of voice. We couldn't hear the lecturer again. No. What's
We
happening?
can't hear him too.
We can't hear
oh,
him
sorry.
too. We are not
Sorry.
hearing you, sir.
Can you hear me now? Can you
We are
hear me now?
hearing now.
Oh, sorry.
But we didn't hear
Anytime
you
you ask,
before.
I'm going to take it again. Anytime you are asking question, I normally mute my mic so that the echo will not be coming in again. Sorry for that. Let me quickly explain again. Now you can take any of this value. So let's say, for instance, now you are taking 110 to 119. So that means that 119 minus 110, you are going to have a value called 9. Add 1 to it, you are going to have 10. Let's say, for instance, I'm taking 80 to 89. 89 minus 80, we are going to have 9 plus 1. We are going to have 10. So that means that is the class width. Let's say you are taking 60 to 69. It's going to be 69 minus 60. We are going to have 9 plus 1. So you can take any of these in class interval to get your class width. That is the shortest form. But if you are the type, you can count your hand and you still get it. So that is for that. So let's move on, please.
Thank you.
Sorry, sir. Sorry, sir.
How did you get the class boundary? The class boundary.
Yes.
We've not gotten to class boundary. We are still coming there.
Okay, sir. Excuse me, sir. I just want to be just for clarification. So what you are saying now is that if we want to calculate the class width, that means the difference between the class interval plus 1.
You are right, ma. Perfect.
All right, sir. Thank you, sir.
Perfect. Yes. You are
All
getting
right.
it. I'm happy. So let's continue. Okay. Now, remember that we are now moving to mode. We are moving down to mode now. Can you hear me, please? Someone should confirm that so that we can move on.
Yes,
we
can hear you.
Oh, good. Oh, good. So let's continue. Now, look at this formula for mode. Please just follow me like that. Now, the first thing is L means lower class boundary of the modern class. So that means that we have to get what we call the class boundary. It is when you now get the class boundary, then you cannot get the modern class. Remember that the modern class is the one with the highest frequency. Let's go and get the class boundary first. Let's go to our table. Now, how do you get your class boundary? It is very, very simple, but it's just, we call it mathematical manipulation, which is mathematically okay. So you don't violate any mathematical rule. That is just simple manipulation. Now, come back to your class interval. You get your class boundary from your class interval. Now, remember that by the time you add this guy to this guy, 60 plus 69 divided by 2, you are going to have 64.5. Note that. It's very, very important. Now, remove 0.5 from this guy, from 60. By the time you remove 0.5 from 60, you are going to have 59.5. But that 0.5 that you are removing from 50, from 60, add it to the next person here, which is 69. So it becomes 69.5. So by the time you add these two together, divided by 2, must give you the same answer when you add these two together and divided by 2. Let me take it again. To get the class boundary, subtract 0.5 from this one, from this 50, from this 60 rather, you are going to get 59.5. Add that 0.5 to this 69, you are going to have 69.5. That is called the class boundary. Now, the beauty part of class boundary is this. The one that is, or the last value here will be the continuation of the next one. If you look at this now, this is 69 here. Then the 69 will be the starting point here. Let's come back to our class interval. Subtract 0.5 from 70, you are going to have 69.5. Add 0.5 to 79, you are going to have 79.5. So that means that the end point of this guy is the continuation of the next one. Now look at this one, 79.4.5 is the end point of this. It's the continuation of this. Then look at this, 80 minus 0.5, you are going to have 79.5. Then 89, add what? Add 0.5 that you subtracted from 80 to 89, you are going to have what? 89.5. So it continues like that until we have the last value, which is 120. Subtract 0.5 from 120, you are going to have 119.5. Then add that 0.5 to 129, you are going to have what? 129.5. That is how we normally derive our class boundary. So let us now move to the mode. We want to calculate the mode. Remember, we want to calculate the mode. Remember that LEM means lower class boundary of the modern class. We've established the class boundary.
Sorry, sir. I'm sorry for cutting you. Yes, sir.
Okay.
The class boundary is the 0.5 constant. Is it a constant number that we have to use before we can get our class boundary?
Okay. Although you can, let me put it like this. If you check different textbook, even check online and some other textbook, it is 0.5 that they normally use. So it is constant. But I've tested it. I use different points. But the only thing that you must be sure is that anyone that you are subtracting from the first one, it is the same number, you must add it to the second one. That is very, very important. So I've tested it with several numbers. I've used 0.8, I've used 0.6, and I still have the same answer. So how do we confirm whether I'm going to have the same answer? Is that by the time you sum the two together, you divide it by 2, you must have the same answer by the time when you are summing the class boundary, class interval, the 60 plus 69 together. You can test it. Use 0.03, use 0.3, subtract 0.3 from here, add 0.3 to this. So by the time you add them together, it's going to give you the same answer. But one thing that you must follow is this: if you are using 0.3 as the standard for your own, you must use it throughout. Don't say that you use 0.3 for the first one, you now want to go and use 0.5 for the second one. No. If you are using 0.3, you use 0.3 throughout. If you are using 0.5, you use 0.5 throughout. If you are using 0.8, you use 0.8 throughout. But 0.5 is very, very common. So that is all about that. So now that you have established the class boundary, now we want to go and dictate the modern class. How do you get the modern class? The modern class is the one with the highest frequency. Just come back to where you have the frequency. The highest frequency that we're having here is 12. So that means that 12 is the modern. So the modern class is 12. Now, you will not trace the modern class down to the class boundary. You trace the modern class. That's why I put it in bold. You will trace this modern class down to class boundary. Then you are going to bring the class boundary out, which is the class boundary that we're having here is what? 89.5 to 99.5. Note that it is very, very important. Let's go back to the formula. Now, what is now the L? L is the what? The lower class boundary of the modern class. Let's go back to our table. Now, look at this table now. The lower class is the 89.5, while the upper class is 99.5. Remember that we first of all locate our modern class, which is what? Which is 12. Now, we trace it down to the class boundary. We have the class boundary of the modern class to be 89.5 to 99.5. Now, from 89.5 to 99.5, 89.5 is the lower class boundary of the modern class, while the 99.5 is the upper class boundary of the modern class. Now, let's move to the formula. Now, if you look at it again, The lower class boundary, which is Elena, is now what? 89.5 from this our table. The lower class boundary is what? The lower class boundary of the modern class is 89.5. So that is our L. That is how we normally get our L. Note that it is very, very important. What is our D? Record that I told us that our D is the difference between the frequency of the modern class. We've gotten the frequency of the modern class. Then and frequency before the modern class. Let's go back to our table. The frequency of the modern class is 12, which is the highest frequency. Now the frequency before you get to modern class is 9. Before you get to 12, we're going to get to 9. So now by the time you do 9, by the time you do what? 12 minus 9, you are going to get your D1. That's what we have here. 12 minus 9, which is 3, is our D1. Now the next one is we want to get our D2. Our D2 is what? The modern class, the frequency of the modern class minus the frequency that follow the modern class. After the modern class, the frequency that follow it is 9. So we are going to do what? 12 minus 9 also. Let's go back. So we have what? 12 minus 9. So our D1 is 3. Our D2 is 3. What is our C? Look at this now. To get my class width, I is what? 69 minus 60, which is 9, plus 1, which is 10. Or you can do 79 minus 70, which is 9, plus 1, which is 10. Now, let me now substitute this into my formula. My L is what? 89.5, which is this guy, plus my D1 is 3. My D1 again is 3, plus my D2 is 3. Multiplied by my C is 10. So now you are going to apply the rule of BODMAS. So you are going to deal with the one inside the bracket first. So we have 89.5 plus 3 multiplied by 10 is going to give you 30. Can you see this? 3 multiplied by 10 is 30. Then 3 plus 3 is 6. So by the time you do that, this 30 divided by 6, we are going to have 5. 5 plus 89.5, we are going to have 94.5, which is the mode of this group data. So one question or two questions before we move to the media. Please, you have the floor.
I have question.
Hello, sir.
Question.
Okay, if you have question, please let us just raise up our hand so that I can call us so that we can maintain order. Okay, Madam Bisola, go ahead, please.
Yes, sir. Sir, can you please go back to the table, sir? There is a question I want to ask. Yes, sir, to the frequency table back, sir. Yes. You know the frequency table, it's from the table, we have our mode, the highest mode to be 12. And you said our D1 and D2 is the number before the modal class and the one behind the modal class. Now, if the number before the modal class, can it be any number? Yes, probably it is lesser than, assuming from the frequency table, we have maybe 4, 6, 3, and then 12 to be the highest number. Then the next number is probably maybe 1 or 4. Are we still going to make use of it like that, or must the number be the same? Did you get my question?
Let me react to that. Yes, I understand. See, whether they arrange it in any way, whether your number is this or that,
Just follow the
first
rule.
thing you have, please, I will call you, please. The first thing that you have to check is your highest frequency. Once you get your highest frequency is your modal class. Now, frequency before you get to the highest frequency is to get your D1 is going to be your modal class minus the frequency before you get to that frequency, the modal class frequency. That is your D1. Now, how to get your D2 will be after your modal class frequency, the frequency that follow it immediately. You are going to subtract that frequency from the modal class. That is how you get your D2. Irrespective of how they arrange the data, your own work is to do what? To locate the what? To locate the highest frequency. So after locating the highest frequency, then you will now you find your D1, which is the difference between the modal frequency and then the frequency before the modal class. Then the D2 will be the difference between the frequency of the modal class and the frequency that follow the modal class. So that is how we're going to get that. So
sir, I'm sorry, sir. I'm sorry, sir. If the frequency that is below or above the modal class is higher than the modal class, can we use a negative number, a negative
you can't
answer?
use that's what I mean. Please let me take it again. If you can't have remember that you are going to check through your frequency. You can't have any frequency that is greater than the modal class, because the highest frequency in that your table is the modal class. So if you're having 13 is your modal class. If you still have anyone that is greater than 13, let's say 20 is your modal class. Did you get it now?
Yes, sir. Yes, sir.
So you can't have any frequency that is greater than the modal class. If you have any frequency that is greater than the modal class, that frequency that is greater than is the modal class frequency. So Murenikeji, you can ask your question.
Thank you very much, sir, for the explanatory lecture. My question is, this higher frequency we are seeing is at the center. We have 7 datas and it's at the center. Is it possible that our higher frequency should be at the second or towards the end of the table?
Okay.
For instance, if our frequency is, if it's at the 100 to 119, is it possible? Or is it even possible for it to be the very last one?
Okay, let me quickly answer that. Your modal class can be anywhere. Now,
okay,
let me put it to the last one. Let's say, for instance, now we have our modal class to be the last one. Now, you can only get D1, and you also get D2. You will get D1, you get D2. How? Now, the D1 will be, let's say, for instance, now we have the modal class to be the last one. So that means that the frequency before the modal class. So that means that 3 minus the frequency that you're having here. But now, since your modal class is the last frequency here, so that means that you are going to subtract 0 from it. That's all. That's all. So that means that you are going to assume that the frequency that follows it is 0. That's all.
Oh,
so your modal class can stay anywhere. Anywhere.
Thank you, sir. Thank you, sir.
Is that clear, please?
Very clear, sir.
Oh,
Thank
good,
you, sir.
good. Okay, you can lower down your hand. Lower your hand. So now, okay. Eyitola. Sorry, Eyitayo.
Yeah, thank you, sir. I understand all this, but this D1, D2, I don't understand how we got them.
Now, the D1 is simply means that look at your highest your modal class. Frequency of your modal class. How do you get your modal class? The one with the highest frequency. The one with the highest frequency here is 12. So now, frequency before you get to this highest frequency is 9. So 12 minus 9 is your D1. Now, frequency that follow your modal class is what is 9. 12 minus 9 is 3. So this one can also, it can be any number. Just follow that principle. Once you get your modal class, frequency before you get to your modal class is your, when you do the difference, is your modal, is your what? Is your D1. Then if you subtract the frequency after your modal class from the frequency of your modal class, you are going to get the D2. So that is how we get our D1 and the D2. I hope that one is clear.
Thank you, sir. Yes, sir.
Okay, good. Okay. All right. Duro Dollar, you can ask your question.
Thank you very much for the job well done. To add to what has been taught so far, to get the class width, I think we can as well use the lowest or the highest class boundary of the first interval and the second interval, as in minus the first interval from the second, class from the second class. For instance, from the table, we can subtract 60 from 70, or 69 from 79, or 80 from 70 from 80, instead of using 60, 69 plus 1. Is it right that way? Are you getting my?
Yes, I understand. I understand your question. Now, remember that it's just mathematical manipulation that we use to get this. So I told us that we are going to add this together and add this together. We must get the same answer. So by the time you do 69 59.5 minus 59.5. What do you get? Do we
It
have
gives
10?
us 10.
Do we have 10 or 9? Please press your
It
calculator.
gives
What
us
do we get?
10. 10. Hello?
Do we have that, please?
It gives us 10. 10.
It is 10.
Okay, do we have 10?
Yes.
Yes.
I want another person to
Likewise,
confirm.
the
It
class
is 10,
interval.
right?
What he's trying
So
to
that means
say,
that you can get
what he's
your,
trying to say
okay,
is
that
that
means that you can
can
get
we
your, what's it
remove
called?
60 from 70, 70 from 80, 80 from 90, and everything is 10? Can we do it to get the width like that? That's what he's trying to say.
I think network has cut him
Now,
off again.
Yes, yes, it can be done.
can you hear me? Can you hear me?
Yes. Yes.
Can you hear
We
me
are
now?
hearing you, sir.
We have you have different way of getting your class width. Are we together? But just make sure that you have familiarized yourself with one, so that in the exam or you won't get yourself confused. If that one is the one that it works for you, fine, you can go with it. So if class boundary is the one that works for you, fine, you can go with it. If 70 minus 60 or 79 minus 69 that worked for you, fine, you can go for it. So we have different ways. It's like a mathematics. We have different formula for solving one problem, but you must arrive at the same answer. So like now, for instance, now we've mentioned like 4 methods that we can use to get our class interval tonight. Is either we count our hand, or we use 69 minus 60 plus 1, or you subtract the upper class boundary minus the lower class boundary, or you do what? You subtract 70 minus 60 or 79 minus 69. So any method that you use, you will still arrive at what? At the same answer. So I don't know, maybe we get that, please.
Yes, sir.
Thank you.
Do we get that, please? Okay.
Yes.
Okay. Can we move on?
Let's move on.
Let's put our calculators to work.
I have a question, sir. I have a
Finish
question.
first.
You did not raise up your hand. You did not raise up your hand.
My
That is
hand
why.
is raised up. My hand is raised
Oh,
up.
okay, sorry. Okay, ma. We've answered a tire. Okay. Then let's person Olufisayo Tinubu. Can we have your question?
Thank you, sir, for how you have taught us so far. With the calculation, please, can you go back to the formula? Sir, please go back to the formula. The formula after this table. Hello, sir. Okay. Yeah, I did not get the C. How you came about this C here? The C that is equal to 10, yes. That is where I got lost. I understand the table so far, but this C is what I'm thinking how you arrived at 10. Thank you.
Well, sorry. According to my understanding, that is supposed to be W, which is the class width, according to the way we were taught. Supposed to be W.
Okay. The class width. Okay.
They can as well use any letter. They can use W, they can use C, they can
Whether
use
it
any letter.
is
Just to
C or
represent
it
it.
is
All
K,
right.
they are called dummy
Thank
variable.
you.
They are called dummy variable. You can use any alphabet. That does not mean that because you see W in a textbook, it is W or two. You can call your own O, provided that you are going to define it that my O is class width.
Yes.
My W is class width. My
Okay,
C is class width. My B is class width. They are called dummy variables. So you can use any numbers. So please don't restrict yourself that it is W. No. It can be any alphabet so far that you are going to define it. If you use W and you don't define it as class width, you will not get the mark. Even though you use W and you don't define it that my W is called class width. Please, you have to divide it. So now, it's just 69. If you look at this, 69 minus 60 plus 1. But during the course of the lecture, someone opened our eyes to see this, that your class boundary, the upper class boundary minus the lower class boundary will still give you 10. Or 69 minus 60 plus 1 will give you 10. Or 70 minus 60 or 79 minus 69, you will still get 10. So for when I was preparing this slide, I used 69 minus 60 plus 1. So that is how we get our what? Our class width, which is C. So the next person ask question.
You have one person more to attend to.
Please go ahead.
Okay, thank you very much for your explanatory lecture. But there is an area that always gives me headache, is how to locate the lower class boundary of the modal class. In this your table, I am thinking that the lower class boundary of the modal class is 90, but you said 89.5. So I'm always confused on how to locate it.
No, that confusion will go away tonight. Let me explain again to you.
Amen.
Now,
Amen.
So you have to first of all establish class boundary. Remember that we need lower class boundary of the modal class.
Yes.
So that means that you first of all establish class boundary. So immediately you establish your class boundary, the one that is lower is 89.5. That is what you need.
Where is the 80? How did you get the 89.5?
That's a very good question. Look at this 90. Subtract 0.5 from this 90. We are going to have 89.5. But the 0.5 that you are subtracting, add it back to the 99. You have 99.5. It is called mathematical manipulation. But how do you know whether you are wrong or right? Add these two together, divided by 2. It must give you the same answer when you add 90 and 99 together, divided by 2.
Okay,
that is how you get lower class boundary.
Am
I clear, ma?
Yes, sir. Thank you very much.
What of the status of that confusion now? Okay.
I've gotten over it.
The status has gone.
We thank God for that.
I've gotten over it. The challenge.
Okay.
Hello,
all
sir.
Right. Okay.
Hello, sir.
I'm with you, ma.
Yes, sir. I just want to ask for the class boundary that she has just finished asking now. Does it mean that once we got the modal class, at least that will lead us to knowing the class boundary that we will take? Is that what you are saying, sir?
Yes.
Once we get the modal class, sir.
Once we get the modal class, then the class with that class boundary is your modal class boundary.
Okay, sir. Thank you, sir.
So, but I know
you know
how to get the modal class now.
Yes, sir. Yeah.
The one with the highest frequency. So let's move on.
Yes, sir. Yes, sir.
Okay. Now the next one is the median. So which you have to come for the median, but it's not add. It's the same thing. Now, the first thing is you have to locate the median class. How do you locate the median class? Remember that the total frequency is what? Is 50. Divide 50 by 2. Divide what? 50 by 2. We are going to get to 25. Please note this. You may be jotting it down. The first step is you want to locate your the median class. How do we locate our median class? Divide your total frequency, divide it by 2. If you divide it by 2, you are going to get what? You are going to get 25. Just follow my step like that. You are going to get 25. Now, come back to your cumulative frequency. Not frequency now. I'm talking about cumulative frequency. Come back to your cumulative frequency, which is this third column. Where can you find 25? You cannot find 25 here because this is 3. 25 is greater than 3. You cannot find 25 here because this is 10. 25 is greater than 10. You cannot find 25 here, which is 19. 25 is greater than 19. But you can find 25 inside 31. Let me take it again. Divide your total frequency by what? Divide total frequency by 2. We're going to have 25. Come to your cumulative frequency. Where can you find that 25? You can't find it here. 25 is greater than 3. You can't find it here. 25 is greater than 10. You can't find it here. 25 is greater than 19. But you can find it in 31 because 31 is greater than 25. So that class that you can find the division that you have here in is called the median class. So the median class here is still what? This. I don't want to use the scenario that your median class is the same thing as your modern class. Your median class and your modern class can be the same in one condition, provided that your data is normally distributed. It is only when you have your normal distribution data that you are going to have this scenario. But so that you will not put that one in mind that the modern class is the same thing as the median class. No, don't do that. If you are given any value or any, you will have a value. Come back to cumulative frequency and locate where you can find that value. Where you can find that value is your median class. Is your median class. So now in this case, our median class is this 12 this particular class that
90 to 99.
Yes, 90 to 95. Okay, let's go to our formula.
Sir, sorry, sir. Before the formula.
Hello.
Yes,
Median
class. Yes, sir. You said that 31. Around that 31 is where we can find our median class. What about 40, 47? They are also greater than 25, just like 31. Can't
Now,
our median class be there?
That's a very good question. But if you are going to this, if you are moving to the next one, that means that the division that you've done here is greater than the one that you left. So if the division that you've done, let's say for instance, after we divide this, it is 35. We can't find 35 here. We move to the next one.
Yes.
But now the division that we've done is 25. It can be here. So you don't need to move to the next one since you can find it here. Did you get it, please?
Yes, sir.
Let's say the division that we have, let's say for instance, we have our total frequency here to be 80. By the time you divide this, let's say for instance, that by the time we divide it by 2, we're going to have 40. So we're going to pick this. Let's say for instance, now we have 75. By the time you divide 75 by 2, we're going to have something like, let's say 70. By the time you divide 70 by 2, we're going to have 35. So that means that you cannot pick this because this one is greater than 35. But 40 is greater than 35. So you stop here. So that means that your class is inside this 40. So we call it the median class. So in our case here that we have 25, 25 is inside 31. So this is our median class. Do we get that, please?
So
yes.
it means
Yes,
so it means that in our cumulative frequency, the first number that is greater than our mean, our mean is the first number we are going to take as our median class.
Yes.
Good. Great. Perfect. Yes, you are right. You are right. You are getting it.
So are we now taking 31 or 90
right.
to 99 as the median class, or we are taking 31?
31.
Remember that we are what's it called? Our median class is this. We use cumulative frequency to dictate our median class, but the frequency of our median class is still 12, not cumulative frequency. Frequency of our median class is still 12, but we use cumulative frequencies to discover our median class. Do we get that, please?
Yes.
Yes.
Okay, Bisoye, go ahead with your question. Peter, let me put it as Peter.
Okay, hello, sir. What the
Yes,
question?
sir.
I mean, the question is this cumulative frequency, which is 31. No, when we get to the median class or our class interval, we are not deducting anything again, like we did for the lower class boundary. So in this case, we will use 90 to 99 instead of 89.5 that we use as lower class boundary. Can you please explain?
Okay. Can you hear me, please?
I'm
Yes, we
hearing you,
can.
sir. I'm hearing
Yes.
you, sir.
So please,
Yes.
let's quickly go there. Remember from our formula, I define all the parameters. The L that you are seeing here is not lower class interval. Please note that. The L that you are seeing here is not lower class interval. Assuming it is lower class interval, you go with 90 to 99. That means that we are using 90. But the L that you are seeing here is the lower class boundary of the median class. Lower class boundary of the median class. So that means that before you can get the L, you must get the lower class, you must get the class boundary for the median class. Before you can get the L, you must get the what? The class boundary of the median class, not the class interval. It is the class boundary. So there is difference between the class interval and the class boundary. It's very, very important. So that is why you have to first of all locate your median class. Once you locate your median class, in this scenario, this is our median class. So in that median class, you now go to the class boundary of the median class. You bring the class boundary out. So in the class boundary of our median class, then you can now pick the one that is the lowest. The one that is the lowest, which is 89.5. The one that is the lowest, which is 89.5, is the lower class boundary of the median class.
Yes.
Not 90.
Thank you, sir.
90 is the what?
Hello, sir.
Is the class interval.
Again.
Thank you, sir.
Hello, sir. Good
Yes,
evening,
sir.
sir. I cannot see the table. Yes, thank you.
Can you see the
Okay,
table?
sir. What is now our median class?
Okay, I will take it one by one. Can you see the screen? Let me start with that.
Yes, sir.
You can see the screen.
Yes.
Okay, please
Yes,
check your
what is our
network.
median? Yes.
Okay.
Our
Now,
median class from this table.
your median class now is now 18. Is now what? Is now 89.5 to 99.5.
Yes, sir. You can see
Thank you.
Yes, ma'am.
Thank you. Yes, sir.
Okay, so let's move on. So now we have our L to be what? To be 89.5, which is this. Now let's go back to our formula. We need N. If you look at the formula of media, we have N divided by 2. We need N. What is N? N is the total frequency that you have. Some textbooks, you can see summation F. Summation F is the same thing as N. N simply means the total number of observations that you have. If you look at our own here, our N total number of observations that we have is 50. Our N here is 50. So N divided by 2 will give you this one that you are seeing here. N divided by 2. Some textbook, you can see 0.5 multiplied by N. 0.5 is the same thing as 1 over 2. Then by the time you do 0.5 multiplied by 50, it's going to give you 25. 50 divided by 2, you are still going to have 25. So that is how we normally get this N divided by 2. Our N is 50 divided by 2. I think that one is clear. Now, let's move to this. This one simply means that cumulative frequency before the median class. Cumulative frequency before the median class. Let's go back to our table. This is our median class. This is our median class, right?
Yes, sir.
Okay. Now you can do it in 2 ways to get this. To get this guy here, cumulative frequency before our median class. I'm going to explain the 2 ways. So you'll be the one to pick the one that you like. Now, after you've located the frequency of your median class, all the other frequency that you have.
Hello, sir. I cannot hear you again. No.
You are hearing him now.
She's not hearing. That's why she's talking.
Please check
It's
your
a
network.
Maybe it's
network.
her
You should check
network.
our network. Check your network.
Can you hear me?
Yes,
Your
sir.
network, please check your network. Okay. So if you look at this, once you locate the frequency of the median class, all other frequency that you have before you get to frequency of the median class, add them together. 3 plus 7 plus 9. That is what they mean by this cumulative frequency before the median class. Let me take it again. Once you locate the frequency of the median class, all other frequency that you have before the median class, add them together. That will give you what? Cumulative frequency before the median class. Or another way around is that once you have the frequency, once you have the cumulative frequency, please mute your mic. Please mute your mic. Okay. The second way that we can use to get it is this. Remember that after we divide this by 2, we locate that the value is going to be in this 31. Then the cumulative frequency that follow 31 before 31 is 19. So you can just pick it like this. This is the 19. Or you add these 3 together, it's going to give you 19. So that is how we got this. We normally get this. Now, FM simply means that the frequency of the median class. The frequency of the median class here is 12, which is this. Then our C is the class width. So by the time we get that, we substitute it into our formula. Look at this now. Our L is 89.5. Our N is 50. Then N over 2 is 25. Cumulative frequency before the median class, 3 plus 7 plus 9, we have 19. The frequency of the median class, we have 12. Then the class width is 10. So by the time you put that in your formula, we are going to have 89.5 plus, you open the bracket, N over 2 is now what? 25 minus cumulative frequency before the median class, which is 19, divided by what? The frequency of the median class, then multiply by 10. By the time you do the justice, 25 minus 19, we are going to have 6 divided by 12, multiply by 10. 10 times 6 is 60 divided by 12. 60 divided by 12, we are going to have 5. Then 5 plus 89.5, we are going to have 94.5. If you look at something here, this is very unique. The value that we got for our median is 94.5. The value that we have for our mode is 94.5. And then the value that we have for our mean is also what? What do we get? 94.5. Now, in a situation whereby, because they can ask you, comment on your distribution or comment on your data set, immediately you see that your mean is equals to your median and is equals to your mode. What did I mean by that? The mean value, the mean of your value is equals to the mode, is equals to the median. That means that that data is normally distributed. That means that that data is what? Is normally distributed. So that is the comment that I have here. Comment on the shape of the distribution. Since the mean is equals to the median, is equals to the mode, the score for follow a normal distribution or symmetrically distributed. So that is how you normally interpret this. Before we move on, can we have 2 questions? Then we move on, please.
Good evening, sir. Well done. Well done. Now, sorry, sir. Back to the table, sir. Yes, sir. Still waiting for the table, sir. Now, you said before we can get our...
Okay, we have the table.
Yes, before we can get our cumulative frequency for the median, where we got our 19, that we are going to add all the numbers before the before we get our highest number for the modal number, which is 3 plus 7 plus 9. Yes, sir. Now my question goes towards that. If our highest frequency for the modal, probably it is 7, You know where this number 7 is located, or number 3 is located. How do we now get?
I didn't get your question. I didn't get your
Okay,
question.
sir.
Can you repeat it?
Yes, you said from the formula, you said cumulative. You said how we are going to get our the 19 number, the 19 answer we got, the last formula. You said it was not the cumulative frequency for the median, that we are going to add all the numbers before the highest number for the highest number of the modal level, where we added 3, 7, and 9 together to get 19. Hope you got my question,
I
sir.
get your question.
Now,
You are
my
not
question
asking that what
is
if
that
we have
yes,
what if we have our median to be 3?
Yes, our median to be 3 or to be 7, probably 3. But let's assume that the highest
Can you
number is
type
3.
your question in the chat box because of network?
Okay.
Can you hear me, sir? Can you hear me very well, sir? Now.
Type your question. Type your question in chat box. I can't understand. I can't hear you. Or you change your location or your network. Okay, go ahead and ask again.
Okay, sir. I said that our
Okay,
cumulative frequency for the median.
Adijat, you can ask your question, please.
Yes, for the median. Well, what I was saying that what if our highest cumulative number for the modal is 3, and the same thing with the median too is 3. How do we now calculate the cumulative frequency for the median, where we got our 19? Do you get my question, sir?
So that means that it is 0. There's no cumulative that you want to calculate. So that means that the cumulative frequency before that means that cumulative frequency before the median class is 0. If your median class is 3, according to this, if the frequency of your median class, the frequency of the median class, if it is 3, according to this, so now the cumulative frequency of the median class is 0.
Okay. All right. Thank
so
you.
that
Sir.
means that the frequency that you're having up is 0. Did you get that?
Yes, sir.
Okay.
Hello, sir.
Okay, please, Madam Adija, you go ahead with your question.
Thank you for the lecture, sir. Sir, please, I don't understand the right
I
skill
can hear
and
you,
left.
ma.
I can't understand the right skill and the left skill that you explained previously, sir.
The right skew and the left skew. It means that whenever your mean is greater than your median, whenever your mean value is greater than your median value, that means it's right skewed. Whenever your mean is less than the median value, that means that it is left skew. But whenever your mean is equals to the mode or is equals to the median, or your mean is equals to the median, that means that it is normally distributed. Whenever your mean is equals to the median, that means that it is normally distributed. But anyway around, if your mean is greater than the median, that means that it is rightly skewed. But if your mean is less than the median, that means that it is left skewed. Do we get that, please?
Yes.
Okay. Can we go on now, or we still have questions?
We can go on, sir.
We can go on.
Okay, let's go on, please. Okay, so that is the end for measure of what? Of location. The measure of location for both group and ungrouped data set. So now we move down to the measure of dispersion. Under the measure of dispersion, I told us that we have the range, we have the variance, we have quartile, then we have the coefficient of variation under the measure of dispersion. Now, range is, what is range? The highest number minus the lowest number. Let's say, for instance, now, if you look at our data set here, the lowest that we have here is 60, and then the highest is what? Is 129. So 129 minus 60, you are going to have your range. That is what we have here. So that is, we don't need to waste more time about that. Then, but I want you to note this. Range is the crude measure of dispersion. When you are hearing the word crude, crude simply means that unrefined from the word crude oil. Let's say, for instance, our crude oil. We can't just take crude oil and put it inside our car. They have to refine it to bring out the petrol. So that means that the value that you are having here is not yet processed. It's still a what? It still contains some data, some what's it called? Some variation that may not really give us the true value that it is range. So that is why we don't normally use range to make decisions sometimes, but because it is a crude measure of dispersion, but it's part of dispersion. So the range simply means that the highest number minus the lowest number. Then we move to the variance. We move to the variance. Now, let me quickly say this. In statistics, generally, we have what we call the large data set and small data set. How do you define your large data set? Anytime you have your observation greater than or equals to 30. Anytime you have your observation greater than or equals to 30, it is called a large data set. But anytime your observation is less than 30, anytime you have your observation less than 30, that means that we have a low, we have a what? We have the small sample size. The reason why I'm saying this is that whenever you're having a small sample size, there is a formula for you to calculate your variance. Whenever you're having a large sample size, there is also another formula for you to calculate your variance. The reason why I'm saying this is that another thing is that whenever you are having ungrouped data, we have different formulas to calculate variance. Whenever you have a group data, we have another formula to calculate variance. So I want you to join in with me as we are launching to variance. Now, what is variance? Variance is the measure of how a set of numbers is spread out. Is spread out from the mean. Let's say, for instance, now you've calculated your mean that you have. Then how far are other observations from the center, from the mean? That is what the variance is checking. Now, it shows how far the numbers in the data set tend to be from the average, which is mean. That's what I just explained now. Let's say, for instance, now you have your value from 20 to 100, and after you've calculated your mean, you discover that your mean is 40. All other values that is not 40, how far apart are they from 40? That is what the variance is checking. How far apart are they from the 40, which is the mean? That is what is checking. Note this: the larger the variance, the more spread out the number of data. So as the variance is getting higher, that means that how will I put it? As the variance is getting increased, that means that all observation is far from the mean. They are given distance from the center, which is the mean. So that is just the simple definition for variance. So let's
Please, again, sir. The voice was breaking. No, we didn't get it.
Okay, Okay. We have variance. Now, let me illustrate this. When you have from 1 to 10, you have from 1 to 10. By the time you find the mean from 1 to 10, you are going to have a particular value. Let's say that value is 4. We have 4 as our mean. Remember that we still use the terminology that the center for mean. So let's say we have 4. Now, all other variable, all other number, when you have 4, you have 5.
Anymore.
Can you hear me?
Yes. Yes.
Yes, sir.
I hear you.
Yes.
Okay.
Yes, sir.
Okay. Now, you remember that 4, we have other number. We have other number that is greater than 4, which are 5, 6, up to 10. Then therefore, we have other number that is less than 4, which is 3, 2, and 1. Now, what variance is checking is that what is now the distance from that 4 to 3 to 2 to 1, or what is the distance from that 4 to 5 to 5, to 5 to 6 to 7. That is what we call the spread. How far apart are other data sets from the mean? That is what the variance is checking. So the good part of this is that we now have formula to check all those things, which is very, very important. So we must know how to calculate our variance. We must know how to calculate our variance. So let me be taking it one after the other. When do we have a small sample size? When do we have a small sample size? Anytime your observation is less than 30. Like for instance, now the scenario that I cited from 1 to 10, my observation there is just 10. It's less than 30. So I have small sample size. Now, let's say for instance, now I have from 1 to 100. My observation that I'm having there is 100. It is greater than 30. So I have a what? Large sample size. Let's say for instance, for the last one, if I have from my 1 to 30, my observation is 30. I have large sample size. It is only when my observation is less than 30 that I'm going to have what we call a small sample size. Do we get that, please?
Yes, sir.
Yes, sir. Yes, sir.
This
Yes, sir.
network
Okay.
is a major problem.
Okay. So now,
Yes, sir.
we now have variance for, remember that we have mean for ungroup data. We have mean for group data. The same thing go with the variance. We have variance for ungroup data, and then we have variance for group data. Now, let's move on. If you look at this slide, for ungroup data, we have the sample variance. Anytime you are hearing the word sample variance, that means that your sample size is less than 30. Your sample size is less than 30 anytime you are hearing sample variance. But anytime you are hearing population variance, anytime you are hearing population variance, that means that your sample is greater than or equals to 30. Now, look at this formula that we're having here. Summation, open bracket, x subscript I minus x bar. X bar that you are seeing here is the mean. Anytime you are seeing x bar simply means the mean. Is the summation of fx over summation f that we've calculated both in ungroup data and group data. So x bar is the mean. The xi that you are seeing here are the data that you have. Data 1, data 2, data 3, data 4, data 5. Those are the xi that you are seeing here. So now, when we get to the formula, when we get to the table, the example, you are going to understand better. Now, divided by n minus 1. Why am I dividing this by n minus 1? Because I have a small sample size. I have a small sample size. That is why I'm dividing it by n minus 1. Remember that a small sample size is a sample that is less than 30. In that case, the variance, it is called the sample variance. So we have the summation xi minus x bar square divided by n minus 1, because we have what we call sample variance. That means that our n is less than 30. That is the reason why we are dividing it by n minus 1. Are we together, please?
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
Yes, sir.
Sorry, sir. What if the n is more than 30?
So that means that it is now a population variance, but we are going to get there. So I don't want to, I'm trying to fast, but I discovered that majority of class, they did not follow me, and that one does not really we can't count it as being profession. Yes, let me put it like that, because if you are teaching, you have to carry everybody along. At least you have to carry everybody along. So that means that the level of your teaching is is okay if you are able to carry everybody along. So that is why
Thank
I'm
you, sir.
trying to slow a bit. Okay, so now please note this. We divide this, we divide the numerator by n minus 1 only if we have a small sample size, which is n minus 1, which is n less than 30. So let's move on. I can hear that mind. Don't
We are
worry.
enjoying
At
it.
the end of,
We are enjoying it, sir. Thank you, sir.
Okay, ma.
Well
So
done,
now
sir.
We are following. Yes.
if you look at this example,
Appreciate you, sir.
we have 4, we have 6, we have 8, we have 18. This is a small sample because this one does not greater than 30.
30.
Now, you are going to any mean that you are calculating from here is a sample what? Sample mean. So that means 2 plus 4 plus 6 plus 8 plus 18. Divided by how many observations do we have? 1, 2, 3, 4, 5. Divided by 5. So you are going to get your x bar, which is what sample mean. Your n is the sample size. What is our n here? If you are following me.
5.
5. Good. Good. Great. So let's move on. Now look at this. This is what we call the population variance. If you look at this symbol, this is called the sigma square. But if you look at the sample, we have the small s square. So if your examiner asks you to calculate the population variance and you discover that your sample size is greater than 30, you must write it in sigma square. Immediately I'm saying sigma square, I know that it is a population variance. So now if you look at this formula now, although it is on group data, it is on what? It is on group data, but the population, I'm using population. So now we now have our denominator to be strictly divided by what? By n, not n minus 1. It is dividing by what? By n. Now, if you look at this, we have moon. This is called moon, mu, moon, mu. This is what we call the population mean. Recall that for the sample mean, it is called x bar. But for the population, it is called the moon. So this is the population mean. So the x bar minus the moon square divided by n, you are going to get the variance of your population, which is called the population variance. Now, another thing that you have to check is this. Please note this. If your examiner asks you that this particular sample that you're having, assume that it is a population. Please take note. If they state it there that assume that it is a population, irrespective of sample size, whether it is less than 30, whether it is greater than 30, we will take it as population. You will divide it by n. Let me take it again. If your examiner asks you that you should assume that this sample that you are seeing here is a population, so that means that you are going to take that sample, that data as population, irrespective of whether the sample is less than 30 or not, because they've stated the condition for you that the data is population data. So at the end of the day, instead of dividing by n minus 1, you are going to divide it by ordinary n, not n minus 1. Do we get that, please?
Yes, sir.
Yes, sir.
We have to understand the concept of this formula before you go to the calculation, because if you don't understand this formula, someone can misuse it. Let me just put it like that. So that is why you have to understand the formula. There is no how we are going to do about statistics. At least you still understand some little arithmetic formula. So please, you have to understand this formula. Maybe by the time you go over this video again, before we meet, our next class is I think Friday. Yes, before we meet on Friday, you'll have just go over the video maybe 1 or 2 times. You will understand it better. But let me recap this variance again. We have sample variance.
We have another class.
Friday.
I'm talking. It's
We
Friday.
have another
Yes.
class on Friday.
That's
That's what
Friday.
he
By what
said.
time, sir? By what
It's
time
the
on
same
No, we
Friday?
have seminar on Friday. That's what I'm saying.
It's still
7
7 p.m.
p.m.
Do you have seminar by 7 p.m.
It's
at
7
night?
now.
Yes, we have seminar by
Yeah,
7 to
7.
10. By 7 to 10 on Friday.
Yeah.
7 p.m.
Yeah, 7 p.m. to
Then,
10
then,
on
then
Friday.
can we do
Yes.
Wednesday then?
Let's.
Can we do
I think
Wednesday
I've dis-
night?
I think I've
No, no,
discussed.
no.
I've
We'll
discussed
make
this
arrangement. The next class will
very.
be on Sunday. Hello,
Okay,
class.
okay, okay.
It
Let's
will be
let's
on
continue.
Sunday. After this
Okay,
class.
good. Okay, good. Okay. Before Sunday, the last.
Okay.
Sorry, if it will be on Sunday, we have lectures, we have virtual class between 6 and 8 p.m. on Sunday.
Then please
Yeah.
discuss that with your class rep. Let's continue, please.
We'll talk it out.
Please discuss that with your class rep. So please do that. Okay, so
Okay, sir.
what am I saying is that you should be able to differentiate between the population variance and then the
And the
sample
sample.
variance. Now, alternatively, if you are the type that maybe this formula is too high for you, you can go with this. The expansion of this, by the time you do the expansion of this, is what we have here. Please mute your mic. Is what we have here. So if you are the type that you love this, you can go with this. This simply means that you have your observation, your data set. Let's say, for instance, now I have my data set here to be 24. Please mute your mic.
Please move your mic. Oh.
Edit, mute your mic.
Okay, let's say, for instance, we have 2, 4, 6, 8, and 18. And I want to use this formula here. The first thing that you are first of all going to do is that you are going to square this. This is going to be 2 square, 4 square, 6 square, 8 square, and 18 square. So by the time you do that, you have this x square already. So summation means add them together. So that means that everyone that you square here, 2 square is 4, plus 4 square is 16, plus 6 square is 36, plus 8 square is 64, then plus 18 square. So that means that by the time you add them together, you are going to have this guy here, summation x square, then minus the summation x all square. It means that you are going to add all these x's here together. 2 plus 4 plus 6 plus 8 plus 18. By the time you add it together, then you will now square it. That is what is summation x all square. It's different from summation x square. Please note this. Summation x square simply means that you are going to square your x's first before you add them together. But summation x all square simply means that you are going to sum all these x's together. Then the value that you are going to have, you will square it. Then you are going to have this. Then divided by the n, which is what? Which is the number of observations that you have. Divided by n there is strictly for this. It's strictly for this. It does not affect this. But the largest one here, that's why I'm putting the long line here. So the one at the numerator here is affecting everything here. So that means that the value that you have for here minus the value that you have for here divided by how many observations do we have here? This is 5 divided by 5. By the time you do the division, you are going to have a value here. Subtract that value from this summation x squared that you've gotten from your squaring of all these 2, 4, 6, 8 all together, then divided by what? 5 minus 1. By the time you do that, you are going to have what we call the sample variance. Now, go back to this. The only difference between this equation 6 and equation 7 is that we just remove 1 because it's a population variance. Any question on that before we move on?
Sir, for that population variance, the alternative formula. So that means there is no represent. So for as a replacement for the mu that we have in the first formula for the sample population variance
that we have in equation 5, yes.
Yeah, so there is no mu in the alternative
there
formula.
Is no mu.
It is replaced by x1.
It is
x1
replaced by
squared.
this.
Okay.
Yes, it is replaced by this.
Okay. Then my second question, sir, it has to do with this x1. in that population, in the sample variance, we
Please,
have
ma, please
X.
wait, ma. It is
Okay,
it is XI. It is
sorry,
XI,
XI,
not
sorry.
X1.
Okay,
Okay.
yes, sir. Okay, thank you, sir. So
Yes,
in the
ma'am.
sample variance in the formula, the one before this, that's XI. So does it mean that for this data that you gave us as an example, that means to calculate our XI, we will use this formula 5 times. That is XI, which is
No.
So how are we
Let me
going to fix? All right, sir.
Let me explain. Now, the XI simply means that this particular I means that
Yes.
whenever my I here is equals to 1, that means that it is the first observation here, which is 2. Whenever this I is equals to 2, that means the second observation, which is 4. Whenever this I is equals to 3, that means that is the third observation, which is 6. Whenever this I is equals to 4, that means it's the fourth observation. Whenever this I is equals to 5, that means this is the what? The fifth observation. So this I cannot go beyond 5 because I don't have I have just 5 observations. That is the meaning of this XI. Did you get that, please?
So that means XI in this formula is 5.
XI in this formula is 2, 4, 6, 8, and 18.
So how are we going to write it? Are we going to say 2 plus 4 plus 2 plus 18?
Yeah, that is why you have this summation here. Recall, summation means add them together.
Okay, summation
Add those
XI.
X's together. Yeah.
Okay. I get it. Now I get it. Yes.
Yes.
Okay. Thank you, sir.
Okay. Yeah, go ahead with your question, please. I'm with you.
Okay. So addition. Yeah, that's true.
What is the mu representing here? In the
mu is the
population
population mean. The mean is for population.
Okay.
Is a population
All right,
mean.
sir.
Anytime you are using
Thank you.
population variance, you
All
use
right, sir.
population mean.
Thank you. Thank you.
Thank you,
Yes.
Hello, sir.
I'm with you. Go ahead with your question.
The first formula for population variance is it the same thing as this the second formula, number 7?
It's
Is
the
it the
same
same thing?
thing.
The formula in number 5, is it the same thing as formula? Okay, so we can use the one in number 5 or the one in number
You can
7.
use anyone. It's the same thing. The expansion of number 5 give room for number 7.
Yes, number 5.
Equation 5. I'm talking about equation 5. That's why I numbered it. So the expansion of this is this, but it's a mathematical expansion. So I don't want to be showing you that. So they will not ask you to derive all this. They just want you to make use of this and you get your answer.
Yeah.
So anyone that you are okay with it, so you can have it. Can we move on?
Yes, sir.
Excuse me, sir. Thank you very much.
Sir.
Definitely according to this formula. Hello.
Someone is talking.
If you want to ask question, please raise up your hand.
5.
Somebody is talking, please.
Question.
Wait.
Hello, ma. Hello, sir.
Mr.
That means according to this formula, the summation xi square means 38 square.
In equation 5.
Please, let's do it normally now. Decorum, please. Somebody is talking and you are still talking.
Thank you, sir. According to this formula, summation xi square means 38 square minus 38 into bracket square all over 5 minus, all over 5 all over.
No.
Hello.
I'm with you. Just go ahead.
All over 5 minus 1. All over 5 minus 1. Is that?
No, sir.
The first one that you mentioned, yes, according to that formula, it is only the first one that you mentioned that is not correct. Why? The first one, which is summation x square.
Si.
xi square, summation xi square. It simply means that you will first of all square your observation. You will first of all square your observation. That is 2 square, you have value for it. You square 4, you have value for it. You square 6, you have value for it.
Okay.
You square 8, you have value for it. You square 18, you have value for it. You now add all those ones that you square together. That is the meaning of that.
Get that.
But the second one here means that all the number that you have here, add them together. You have a particular
It's
number. Then now
38.
square that particular number that you have. Did you get it, sir?
Yes, sir.
Okay, good. Okay, next person, please ask your question now.
Thank you, sir.
You're welcome. Please, next question,
Yes, sir.
please.
Thank you very much, sir.
Okay.
Population variance, equation 5.
Go ahead, please.
Hello, sir.
I'm with you.
Population variance on equation 5. Please, can you teach us how to get that?
Good. What you just need to get here is this. Let me
Hello,
go back.
Sir, can you hear me?
I can hear you. Let me take it there. Let me take you there, please.
I'm asking that you should teach us. Okay.
Let me take you there, please. Okay. Now look at this. Now I want to use equation 5.
Okay.
Yes. Let's mute our mic and let me explain this, please. We want to use equation 5. The first thing is that you are going to get to this your population variance, assuming that we are taking this as population variance, as the population data. That means that add everything here together divided by 5. You are going to get this population mean. 7.6. Good. So that means that you will create a column called xi minus mu. That is xi minus the population mean. So now in that column, you will not be taking it one by one. The first one is going to be 2 minus 7.6 that you get for your mean. That is for number 1. Number 2 is going to be 4 minus the mean that you have, which is 7.6. That is number 2. The number 3 is going to be 6 minus 7.6 that you have. The number 4 is going to be 8 minus 7.6 that you have. The number 5 is going to be 18 minus 7.6 that you have. You have that column called xi minus mu. Are we together?
Yes, sir.
Good. Now, you create another column, which is the second column now. You create another column, which is the second column, called xi minus mu all square. Xi minus mu all square. What did they mean by that? Remember that the first column is xi minus mu. So that means that all those values that you have, when you carry out 2 minus 7.1, you will square that value. That one will give you x minus mu square for the first one. The second one, remember that the value that you have when you do 4 minus 7.6, that value you will square it, will give you for the second one. You will square it, will give you for the third one, fourth one, up to 18. That column is called x minus mu all square. It is not that column that you are now going to add all together down. That is the meaning of summation x minus summation xi minus mu all square, then divided by the number of observation, which is 5. That is how you can apply this number 5 formula. Go ahead with your question if you have question.
So, sir, it means our answer for some of those xi, we can get negative answer, because if you are doing 2 minus 7.6, it will give us a negative answer. 4 minus 7.6 will give us a negative answer.
Yes, but when
we square it, it will go back to positive.
Yeah, okay. Negative times negative will give you positive.
Yes, will give us positive.
Yes. So any other question?
Please mute your video or whatever. The last speaker, please.
Excuse me, sir. Oh, sorry. Oh, okay. Yes, I still have a question further. So by the time we get the respective value for xi, well, whether negative or positive, We will now add all the values and then square it.
No.
Is that for mu? For
You
our
mean for
xi
which one?
minus, you know,
We will
we'll
square
first do xi minus
individually.
mu. Okay, we'll square
You will square
individually.
it individually.
Okay.
Yes.
Okay. Then
Look,
when we
look at
now
this.
square it individually.
Wait. Look at this. Let me see. I didn't use that second method. Yeah. I used the first
2
method. I
minus
used the second
1.6
method.
squared.
Okay, let's see. Oh yeah, please go ahead.
Okay.
Go ahead, please.
With the question. Okay, so what I'm saying is, so that means each category we will do for instance, 2 minus 7.6, whatever it gives us, we'll square it and note it.
Yes.
That's our x. Okay.
Yes.
So we'll do it for the
Yes.
various, for all the 5 datas.
Yes.
We do it
Yes.
individually. Now,
And now
after
sum
doing
it
it
up.
individually, we'll now sum it up. Okay.
Yes.
Thank you, sir.
Any question again? I can hear that sign.
Sir.
Okay.
Well done,
Please,
sir.
I want you to get this concept of variance. The calculating part is very, very simple when you understand the concept.
Yes.
Hello, sir. I have a
Please
question.
go ahead. Please go
Yes,
ahead.
sir. I don't understand where you're getting this 7.4, 7.6. Where are we getting it from?
2 plus 4 plus 6 plus 8 plus 18 divided by 5. What do you get?
Okay.
7.6.
Okay, sir. 7.6. Okay. So you now
Is it
use
clear
it to...
now?
Yes, sir. Okay, sir. Thank you, sir.
Okay. Any other question? So, let me quickly explain the group data. Let me quickly explain the variant for group data now.
Okay.
Can you see this? Now,
yes, sir.
The variance for group data, record that if the same procedure, remember that when we started with the mean for group data, and then the mean for group data, we introduce frequency. The frequency here simply means that after you've gotten your xi minus x bar square that I explained, the second column that you have, instead of now summing it up straight, you will not sum it up yet. Then you are now going to multiply it by each of the frequency. The first one multiplied by the frequency of the first one, the second row multiplied by the second frequency, the third row. You will continue like that. That is when you are going to get what? F into bracket xi minus x bar all squared. So by the time you sum them together, we are going to have what we call the summation f into x minus x bar square all over the summation f. Something is wrong here. Who can tell me?
Can you come again, sir, please?
Which one? Which one?
What you just explained now, sample variance for group data.
Okay, sample variance for group data. Remember that you are going to group it, right?
Yes. Yes.
And by now we know how to group from this to this, from this to this. Okay. Now after grouping it, you are going to find your x. To get x for group data. I've explained that to us. That means that you are going to find the middle value, the from your class interval, the upper plus the lower divided by 2 will give you the middle value, which is x. Now we know how to get our x bar. Our x bar is the summation fx over summation f from our mean. I don't know, maybe you get what I'm trying to say. Your x bar now. We're not talking about the group data. Remember the formula for mean for group data is summation fx over summation f. By the time you perform that, you are going to have what we call the x bar. So now each of the x bar, subtracting it from the x bar, subtracting it from each of the x's that you have. So by the time you do the subtraction, we are going to have the column called xi minus x bar. So that is the first column that you're going to have. Then the next column is going to be xi minus x bar all square. which is this guy here. So after getting that, then each one, which is what the next column is going to be f into x minus x bar all square. Recall that the first one is x minus x bar, which means that you are subtracting your mean from each of the x's that you've gotten. Now, the second one will be x minus x bar all square. That is all the value that you've gotten from x minus x bar. You'll be squaring them one by one. That is what will have to be x minus x bar square. Now, after getting x minus x bar square, you will now create another column called f into bracket x minus x bar square. That is all the value that you've gotten, each one that you've gotten for x minus x bar square, you will now be multiplying them one by one with their frequency. So the first one is going to multiply by the frequency of the first one. The second one is going to be multiplied by the frequency of the second one. The third one is going to be multiplying by the frequency of the third one. The fourth one is going to be multiplying by the frequency of the fourth one. Then at the end of the day, you have a column called f into x minus x bar square. So by the time you now add them together, that is why we have this summation. By the time you now add them together, then you have this numerator called summation f into x minus x bar all square. That is how you can get your numerator. Now, what I'm trying to say here is that remember, anytime you are having a sample variance, that means that you are having a sample that is small sample size. So that means that your n is less than 30. So, and I told us that when your n is less than 30, you have to subtract 1. So that's what I'm trying to ask you here, that what do you think it is wrong here? So it's supposed to be summation f plus 1. Did you get that, please?
M plus 1 or summation n minus 1.
Yes.
Yes. So
this will be
summation
f
is
minus
the same
1.
thing as your n.
minus
It's the
1.
same thing as your n. So it's going to be summation f minus 1 because it is a sample variance. But anytime you discover that your sample is not 30 or your sample is greater than 30, you will not put 1 again. It's going to be summation f only. Do we get that, please?
Yes, sir. So it means that equation 8, there's an omission. It should be summation f minus 1.
That is why I'm asking you that what is missing here?
Minus
so
1
it's supposed
is
to
missing.
be summation minus 1 is missing. That means that you are getting it.
Okay.
So minus 1 is missing. Did you get that, please?
Yes, sir.
Okay, good. Now, with the same thing go with the population variance. The only thing that we're going to remove from here is that we remove the 1. So this one is correct with this. And then the x bar now will now change to mu, which is the population variance. So you can also go with that for this. It's still the expansion of the one that we've done. So since you've discovered that this one has the error of minus 1, that is why I'm putting it here again. So that we can know that this guy here is not correct. You have to put minus 1. But if you don't understand it, you will not know whether it's supposed to be minus 1 here or not. So just to check whether you understand what I'm saying. So we have it correctly here again. By the time you do the expansion here, we're going to have it. This one is more or less like this, but this is for ungrouped data, while this is for group data. So the same thing go with the variance. So let me welcome question, because by my time here, this is 9:30.
9:30.
So we spend more than 2 hours. Okay, so let me welcome question, please. Are we still together?
Yes, sir.
Yes, we are
Yes.
with you.
Yes, sir.
Yes,
sir.
Let me take it that you are with me. Okay, wait, let me be taking it one by one. Okay, let me start from the euro dollar. I can ask your question. Let me take it one by one. Okay, you don't ask questions.
Good evening once again. Thank you very much, sir.
Good evening, sir.
If I want to ask a question, that your meal is where I was lost because I got distracted when you got there, and I didn't want to disturb the class. Getting the meal. I'm sorry. Thank you, sir.
The mu is the population mean. It's still the same process. The way you normally calculate your mean, summation fx over summation
Summation
f.
F over
But this
summation
time
F.
around, summation f, yes. But this time around, if the question is telling you that assume population for this data, that means that you are going to use mu, which is population mean. Did you get that, please? So we normally use mu to denote a population mean, while x bar to denote the sample mean. Do we get that, please?
Yes, sir.
Yes, sir.
Come
Okay,
again,
good.
sir.
We normally use
Come
x
again,
bar.
sir.
We normally use x bar for sample mean, but we use mu or mu for population mean. Do we get that?
Yes, sir.
Yes, sir.
Okay. Okay.
Yes, sir.
Oluyomi Lawa, you can go ahead with your question, please. Oluyomi Lawa, you can go ahead with your question.
Thank you, sir. What I want to ask is that can we
Okay.
put a value so that we calculate and all of us will get the answer that we know that we are following well.
Okay. Okay. You can put a value. You can put a value. So I'm going to the same data that we use. This the same data that we use for group data for mu, for mean, median, and mode. You can use it, try it, and so that you're going to get the variance. Okay.
All right.
Olufisayo Tinubu, you can go ahead with your question, please.
Thank you, sir. That was what I wanted to ask to say. We also going to for the variance, just like you taught us earlier in getting the mean, median, mode. So the last person, what I want to add is that we still need to create a column.
Sorry, please. I don't know. I can't get that question. I didn't get it.
Like the last question topic created, finding the mean, median, mode. If we are going to look for this variance, maybe the population, do we still need to create columns?
Yes, you have to create columns. Yes. You have to create columns. You have to, please. Okay, before I okay, someone was asking that we don't allow to enter, something like that. There's an issue, sir. Some of us, these are yet to be admitted. Everybody is inside now. Okay, let me take the next question. I'm going to call you, please. Madam Elizabeth Babajide, go ahead with your question, please.
Thank you very much, sir. Sample variance on equation 8. Is it the same thing as equation 10? Because in equation 10, yes, there is submission f minus 1, but in equation 8, under it is just submission f. Is it the same?
Okay. Let me throw the question back. What do you think is wrong
Yes,
with
sir.
equation 8? What do you think is wrong with equation 8?
-1 is missing.
Can you hear me?
Equation 8, there is submission f only. There's no -1.
So -1 is missing. So you put -1 there.
Okay.
You put -1
Thank
there.
you.
Okay. Any other question?
Yes, sir.
Olubukola.
Yes, sir. Still to buttress on our question.
Okay.
Does it mean that equation 8, assuming it has that -1 in it, is an expansion of equation 8 is equation 10?
Yes.
Okay. And expansion of equation 9 is equation 11.
Yes.
All right. So we can use either of the two.
You can use it. You can use it. Just pick the
All right.
one. That is why that's why I'm
That
putting
is
everything
easiest
out.
for us.
Just
Okay.
pick the one that you are okay with.
Okay. Then I want to ask, if we decide to apply equation 10 or 11, are we still going to draw that table of x minus xi minus x bar or
You have to
xi
draw it.
minus mu?
Look at my own. Did you see the way I drew my table? Can you see? Can you see? Can you see? Can you see?
Okay. Yes, sir.
Can you see? Okay.
Yes.
Okay. So you do that.
Okay.
Please, can we go back to that table, sir? For X and X bar, sir.
The table.
Do you mean this?
No, sir. The one that has X and X bar, sir.
You mean this? Okay, x minus x bar.
Yes, sir. Thank you, sir.
You screenshotted it, bar? Or you snap it? Which one?
Hey, I cannot see any table.
It's your network. So by the time we come back the next class, that your class rep is going to give you the information about. So we are going to start with the calculation of this.
Please, we need that table. Please, let's snap it for our perusal, please. Can you please go back to that table for us? Thank you, sir.
I think he promised to send the materials to us. So we will still have it constantly. The lecturer promised to send it to us or to the platform. Then we will have it constantly.
Yes.
Do you still need material?
We need it, sir.
Yes, sir. Yes, we need it.
Yes, so,
No,
yes,
I promise recorded
Yes,
video.
we need it to.
I promise recorded video. I didn't promise material. I promise recorded video.
But sir, this table does not have summation x. It doesn't have x high minus by x.
This what?
Hello, sir.
This table doesn't have xi minus by x. It doesn't have the table.
All these 64.5, 74.5, I didn't know the I. I've explained to you that when your I is equals to 1, it means the first observation. When your I is equals to 2, it means the second observation. When your I is equals to 3, it means the third
those
observation.
are x. Okay. So we'll just do the computation.
So don't look for any I. Check your observation.
Yeah.
Okay.
Okay.
Any other question before we call it a night? It's almost 3 hours. So you have to understand it. Okay.
Thank you so much, sir.
All right. Let me check the box. Do you have any other question?
Hello,
there?
sir. Hello,
Yes.
sir.
I'm sir.
Hello,
I'm Ma.
sir.
Yeah. Yes, Ma.
Please, my name is Aware Comfort. Thank you very much, sir, for your effort so far. Can you give us the slides for today's lecture for us to revise before the next